Good morning. We'll try to make this one quick. This is stuff that you should know, but we're going to review it and you're going to do a quick practice. We're going to talk about numerical operations. So first of all, let's review some of the number properties. The commutative property, that's the property that says the order in which numbers are added or multiplied doesn't matter. So, for example, a plus b is the same as b plus a, or a times b is the same as b times a, which of course you know, but remember that's the commutative property. The associative property says the way in which numbers are grouped when more than two numbers are added or multiplied does not matter. So, for example, if you're adding three numbers, a and b and c, you could add together a and b first, or you could add together b and c first, and it doesn't matter, it's going to remain equal. Same thing with the product. A times b times c is the same as a times b times c. Another property that I know you know is the distributive property. It relates multiplication and addition or subtraction. So let's look at how I've written this here. A times b plus or minus c. So that plus or minus has to go in order. So for example, a times b plus c would equal a times b plus a times c. A times b minus c would equal a times b minus a times c. A couple other properties I want you to remember. The identity property, adding 0 or multiplying by 1. If you add 0, you get the same value, so a plus 0 is 0. If you multiply by 1, you get the same value, a times 1 is a. The inverse property, adding an opposite equals 0, or multiplying by a reciprocal equals 1. So a plus negative a will always equal 0. A over b times b over a equals 1. Just familiarize yourself with the names of these properties, and I think you're fine. All right, absolute value. This is an important one because I've seen it in a couple of different types of problems on released items. The absolute value of a number is its distance from 0 on a number line. So because it represents distance from 0, it's always positive. We've talked about that a lot in class, so I know you know that. So first of all, let's talk about how it relates to order of operations. Absolute value is a grouping symbol like parentheses. So we'll talk about order of operations in a second, but just remember, since it's a grouping symbol, you treat it like it is a parentheses and do what's inside the absolute value bars first. So the absolute value of 50 is of course 50. The absolute value of negative 50 is of course 50, because both of those numbers are exactly 50 units away from 0 on the number line. But what if I had an expression like this? 12 plus 9 minus the absolute value of negative 14. Well, I need to simplify this term first because that's in a grouping symbol. So this is going to become 12 plus 9 minus the absolute value of negative 14 is 14. And so then we have 21 minus 14, which is 7. All right, let's talk about how we can use absolute value to find distance, and this is one of the most common ways I've seen that this is tested on the Ames released items. Let's say we want to find the distance between 4 and negative 5. What we can do is find the absolute value of the difference of 4 and 5. So let's take a look at this expression. We have the absolute value of 4 minus negative 5. So that's the absolute value of 4 plus 5, which of course is 9, and the absolute value of 9 is 9. Now it's important to note that the order doesn't matter, and that's what's so great about absolute value. If instead I had done the difference of negative 5 and 4, negative 5 minus 4 is negative 9, and then I take the absolute value of negative 9, I get 9. And you can see that if you look at these numbers on a number line. Here's negative 5, here's 4. There are 9 units between those two numbers. All right, positive and negative numbers. Integer operations. You guys have to know how to do this stuff. I know you do, but let's review some of the basics. Addition, subtraction, multiplication. Addition. If you're adding two numbers, the sum is always positive. If you're adding two negative numbers, the sum is always negative. So a negative plus a negative is a negative. For example, negative 4 plus negative 16 is negative 20. What if you're adding two different ones? The sum of one positive and one negative number will be that will have the sign of the number with the greater absolute value. So let's look at an example. If I were adding a positive plus a negative, my answer could be positive or negative depending. So if I had 12 plus negative 8, I'm going to have a positive result because 12 is bigger, it has the greater absolute value. If I'm adding 3 plus negative 17, I'm going to have a negative result because the negative number has a greater absolute value. 17 is greater than 3. Same thing is true if you reverse the order. A negative plus a positive really works the same way. So negative 9 plus 28 is going to be positive because 28 is greater. Negative 20 plus 15 is going to be negative because 20 is greater than 15. So here you're just finding the difference between the two numbers, and then you take the sign of the number with the bigger absolute value. If we're subtracting, the difference of a positive and negative number can be, of course, positive or negative. So there's a couple different situations you really want to think about. If you're subtracting two positives, this could be positive or negative. It's going to be positive if the first number is bigger. It's going to be negative if the second number is bigger. If you're subtracting two negatives, remember when you have minus a negative, this is really like adding the number. So for example, let me erase that here. Here we have negative 5 minus negative 11. When you have two negatives next to each other, that's like turning it into addition. So negative 5 plus 11 is 6. Negative 23 minus negative 8 is negative 23 plus 8, which is negative 15. Now, if you are subtracting a negative from a positive, that result will always be positive. Again, 19 minus negative 2 will be positive 19 minus negative 2 becomes 19 plus 2, which is 21. If you have a negative minus a positive, the result will always be negative. For example, negative 8 minus 32 is negative 40. Multiplication and division. What you got to know about these is that the rules are same for both multiplication and division. You multiply two positives together, you'll get a positive. If you divide two positives together, you get a positive. Here's some examples. 4 times 7 is 28. 27 divided by 3 is 9, of course. Well, what about two negatives? When you multiply two negatives together, you always get a positive. When you divide two negatives together, you always get a positive. So for example, negative 2 times negative 11 is positive 22. Negative 64 divided by negative 8 is positive 8. Now, if you have one positive and one negative multiplied together or divided, you will always get a negative answer. So for example, a positive times a negative is the same as a negative times a positive. That result will be negative. A positive divided by a negative is the same as a negative divided by a positive. That result will always be negative. So, for example, 6 times negative 8, negative 48. Negative 3 times 14, negative 42. 34 divided by negative 2, negative 17. Negative 20 divided by 4, negative 5. So these are great little examples just to keep in your notebook as you're working through practice problems with your integer operations, so you can see, okay, well, what's my problem like this one? Should my sign be positive or negative when I'm done? All right, almost done. Order of operations. You guys have all heard PEMDAS. There's a couple areas that I really want to highlight when it comes to order of operations, and that's where kids make their most common mistakes. So we know that PEMDAS stands for parentheses, exponents, multiplication and division, and then addition and subtraction. And this is the order in which we want to simplify some sort of expression. So P stands for parentheses, but I'm going to say parentheses or grouping symbols, because there's a lot more things besides just parentheses that can enclose a particular portion of an expression, and you have to simplify it first. So simplify anything in your grouping symbols first. That can be parentheses, that can be absolute value, it can be brackets, it can even be a fraction bar, because a fraction bar gives you a separate numerator and a separate denominator. Then after we simplify stuff inside of parentheses, we're going to simplify any expressions that have roots or exponents. So that's an important thing to remember here. We also have square roots that we have to simplify. Then we perform multiplication and division in order from left to right. So let's consider a couple examples. If I perform my multiplication and division in order from left to right, I would do 60 divided by 2 first, which is 30. And then 30 times 3, which is 90. The common mistake that I see most often that students make is instead of doing it from order left to right, they do the multiplication first and the division second because M comes before D. Well, what happens if I did that here? Multiplication first makes that a 6, so we have 60 divided by 6, and 60 divided by 6 is 10. Now, we obviously can't do these either way and get the same answer. So don't do it that way. Do it in order from left to right. So be thinking about that. Same thing is true of addition and subtraction. Has to be performed in order from left to right. Let's take this example. 5 minus 3 is 2. 2 plus 2 is 4. I did that in order from left to right. But what if I did the addition first? Then this problem becomes 5 minus 5, which is 0. Again, not the same result. Make sure you're going from left to right. All right, last little bit here, a quick refresher of scientific notation. Scientific notation, in a nutshell, is written as a decimal times 10 to a power. So a couple things I want you to remember is that this exponent can be positive or negative. If the exponent is positive, you're looking at a number that is much bigger than 10. If that exponent is negative, you're looking at a really, really tiny number like 0.00, whatever. This number here, the coefficient, has to be a number between 0 and 1. Just kidding. Has to be a number between 1 and 10. Just checking to see if you're paying attention. Now, when you're working with scientific notation and different operations, I'm just going to talk about multiplication and division here. You want to multiply the coefficient, and then you're going to add the powers of 10, and that goes back to our rules of exponents. So for example, if I had 3.4 times 10 to the negative 4 times 4.2 times 10 to the negative 7, what I'm going to do is multiply 3.4 times 4.2, and then I'm going to have times 10 to the negative 4 plus negative 7. That's going to give me 14.28 times 10 to the negative 11. Remember I said that that coefficient had to be a number between 1 and 10? That's what I really said. And that's not a number between 1 and 10. So what we have to do is move the decimal point and make that 1.428. But since I moved the decimal place, I need to increase the exponent by 1. So our final answer will be 1.428 times 10 to the negative 10. Now, if division is the problem that you're looking at, it's the same kind of idea. We're going to divide the coefficients, but this time we're going to subtract the powers of 10. So if we had 4.5 times 10 to the 8 divided by 7.2 times 10 to the second, we'll have 4.5 divided by 7.2, and then we'll have 10 to the 8th minus 2. So dividing this gives me 0.625 times 10 to the 6th, because 8 minus 2 is 6. Now again, I want my number to be between 1 and 10, so I'm going to move the decimal place to the right 1, which means I need to decrease my exponent by 1. Yep, so we have 6.25 times 10 to the 5th power. So make sure your final answer is written correctly, because it wouldn't surprise me on a multiple choice test, both 0.625 times 10 to the 5th, or 10 to the 6th, and 6.25 times 10 to the 5th. I wouldn't be surprised if both of those were answer choices. If this was A and this was B, B would be the correct one because it's written in the correct scientific notation. Okay? That's it. I'm done.